Welcome, everyone. Hi, welcome everyone to our latest Sphero session on engineering design. As we are getting ready to go here, if you don't mind, please make sure you set your chat to everyone so that everyone can see all of your posts and comments in there, not just the panelists, and also introduce yourself in that chat and where you're from. All right. Getting a bunch of people still joining. So we'll get started in just a few minutes here. For those of you that are just joining right now, please make sure you set your chat to everyone and not just host and panelists, and introduce yourself in the chat. All right, it looks like we have people all over the country, which is awesome. And the UK. All right, one last reminder for those of you that are just joining, please make sure you set your chat to everyone and not just the host and panelists, and introduce yourself in that chat window. And we're gonna get started here. All right, our webinar tonight on engineering design with Sphero will take approximately 30 to 40 minutes, and we'll have a question and answer session at the end. So if you do have a question, please post it in the Q&A section of Zoom, and either we'll answer it live or one of the moderators will answer that for you. This will be recorded and emailed after the webinar, and also an opportunity to fill out a form for a PD certificate for professional development. Again, please make sure you set the chat to everyone so that everyone can see anything that you post in the chat, not just the host and moderators. And any questions, again, please post them in the Q&A section. We do have closed captions enabled, and make sure you hang around for the end of the session tonight. We are having a giveaway at the end. All right, so our agenda for tonight, we're going to talk about that engineering design process. We're going to show some examples of how to use Sphero products in the engineering design process. So we'll take a look at Blueprint, Little Bits, Bolt, and Rover specifically tonight. Again, we'll have that Q&A section at the end, as well as the giveaway. My name is Brad Fessler. I am the Professional Development and Content Manager here at Sphero. I worked in public education for 15 years, teaching technology and engineering before coming to Sphero. And I'd like to introduce you to Adrienne Emerson. Take it from here, Adrienne.
Awesome. Thank you, Brad. My name is Adrienne Emerson. I'm an education content manager here at Sphero. Just like Brad, I previously worked in public education, teaching math, engineering, and robotics. And I actually have over 25 years of experience in competitive robotics inside the high school robotics space. So I have been using the engineering design process in the classroom for a really long time, and I'm really excited to talk about how everyone can put that process inside their classroom with Sphero products. So let's get started by talking about the engineering design process and some of the differences that you may see if you Google the engineering design process, you're going to have so many things that pop up. The first thing that I want to say before we start this presentation is there are lots of different versions of the engineering design process. You can go to any site, any program, any product, and you're going to find some sort of iteration on what is shown on this slide. This is the engineering design process that we use. but it might not be the one that you want to use in your classroom. You may have another one that works really well for you, that your kids understand better, that has less steps. And we're actually going to show you a couple examples in this presentation of different design processes that we use, even just within our Sphero line of products. So for Blueprint specifically, the engineering design process shown on this page is a version based on the engineering design process from teachengineering.org, which was developed at the University of Colorado Boulder. So the first steps in the engineering design process are really about making sure you understand what the problem is. A lot of students struggle with these beginning steps and these, answering questions, figuring out what their problem is, and planning. A lot of students, when they get a challenge where they want to, where they have to design something, they just want to jump right in and build. And we're trying to help them understand that within the design process, you want to take a step back right in the beginning to really understand what the problem is that you're trying to solve. So, every year when I was in the classroom, I would open up my lecture on the engineering design process with the same story. Y'all have maybe heard this story before, but if you haven't, I encourage you to use this in your classroom as well. I learned this from a mentor years and years and years ago. So the story goes, um, there is an apartment complex and it's like 20 stories high. And all of the people living in the complex were complaining that the elevator that takes them up and down to their floors is too slow. So they just keep getting complaints about the elevator being so slow. So being, good landlords that they are, they start to try and solve this problem by reaching out to different engineering firms to solve the problem for them. So they get 3 different quotes. First quote, first company says, "We can fix your problem. You need to upgrade all of the motors on your elevator. They're just not strong enough. They don't go fast enough. So you have to upgrade them all. It's going to be $15,000. Second company comes back and says, "No, you don't need any new hardware. This is all like a software optimization problem. We just need to rewrite all of your software, and we will make sure that the elevators are, going up and down and stopping at floors in a way that makes sense. It's going to speed everything up. It's going to cost you $60,000. The third engineering firm comes back and says, "Hey, we can solve your problem for $500. The landlord goes, "What? All the other quotes are like so expensive. How are you so cheap? How are you going to solve our problems?" And they said, "Well, your problem isn't that the elevators are too slow. It's that people are complaining about the elevators being too slow. And if you put mirrors in your elevator, no one's going to complain anymore. They're going to be fixing their tie. They're going to be making sure their hair is straight. They're not even going to notice the time passing in the elevator to complain that it's too slow." So um, that is why it's super important to understand what your problem is. And it's not always the first thing that pops into your head. So like I said, I always start my engineering design process lecture with that story to help kids understand, like, hey, sometimes it's not what it appears on the surface. So again, this version of the design process starts in a way that helps student define the problem. So we're going to ask questions about how to define the problem and the constraints that we're under. Are we under time constraints because they have to do this in one class period? Are they under materials restraints? Are they under any sort of other restraints that they can think of? Then they have to research the problem. So this is 2024 and the internet exists. I tell kids, if you're not Googling before you solve a problem, then you're just doing extra work. I like to work smarter, not harder. Let's research people that have already solved this problem. Can we get ideas from that? Again, an old mentor once told me, steal from the best and invent the rest. And so that's what I tell my kids too. Let's see who else that's probably smarter than us has already solved this problem. What can we learn from them? Then after that, we want to start brainstorming possible solutions. And this is the point in the process where there are no dumb ideas. Everything is important in this part of the process to document all of the ideas, because some silly idea from one person that is never going to work may spark an idea in somebody else's mind that may actually be plausible. So we want to make sure that everybody understands that in this part of the process, it's all about quantity of ideas, not quality of ideas. Then, after we've researched the problem, we've defined it, and we've imagined all these possible solutions, now we're actually going to plan the solution that makes the most sense to us. So, look at all of those possible solutions, ideas, and determine, based on our constraints and the problem that we're facing, what is going to be the best solution in our case. And then the next thing that Sphero is really good for is building prototypes. We have lots of products where you can build prototypes with really easily. And this is so that you can create and test your solution. And then once you've tested, you can iterate and find ideas to improve your design. Many things that we build don't work the first time. That's why it's called Formula 409, because it was the 409th iteration of that product. And then afterwards, communicating the results, often a very important step so other people can see your solution. So again, there's lots of different versions of this design process. This is just one of them, but the basics of all of them are the same. Figure out what the problem is, prototype some stuff, make it better, share your results with people. So let's take a look at how to do this with some Sphero products. The first product that we're going to take a look at is the design process with Blueprint. So we typically recommend Blueprint for grades 6 through 10. And we've made it really easy to start out using your Blueprint kit with the design process immediately. Included with every single Blueprint kit are 5 challenge cards, one of which we have up on the screen here. It says it's called Bridging the Gap. It's about building a bridge that can hold a certain amount of weight and has a bunch of restrictions on it. So it can only be so long, it can only be so high, and other stuff like that. So these cards, again, come in every student kit. You can open up the kit and immediately start doing this engineering design process. And included in those challenge cards is a QR code that takes you to the student handout, which you can see on the right side of your screen, that helps students walk through that engineering design process on their own. So step 1, define the problem. It cues them to write down what that problem is. And then step 2, researching. And again, it cues them to write down exactly what they've researched. I said in that first slide, this is the part that students usually struggle the most with, these first parts of planning. And so anything we can do to encourage them to take a step back, take a breather, not just start building right away, and actually doing some planning is going to be super helpful. So that's why we have these student handouts here to kind of walk them through that process. So once you have maybe done the challenge cards and the students have been introduced to the engineering design process, within the Blueprint curriculum that we have available online, we actually get into this a little bit more. So we have 3 levels of lessons included in our Blueprint curriculum. Level 1 is just figuring out a basic concept of engineering, but level 2 and level 3 is where kids get to get creative. So you can see on the screen an example, one of our level 2 lessons where students will use the engineering design process is to make a art machine out of different linkages and levers. And so they actually figure out how they can design something to make different shapes using Blueprint pieces. And again, in that lesson, included in that lesson is a student handout that walks students through this engineering design process to, again, really encourage them not to skip those first steps. So they want to plan out, they want to sketch, they want to figure out what their restrictions are, they want to do multiple prototypes and iterations, and the student handouts are really going to help walk through students through that. So the next, oh, sorry, I was moving on to little bits too soon, forgot about this slide. So, but the other cool thing about Blueprint is you can use it with these lessons, but you can also use the Blueprint kit to make your own lessons. So you should be able to modify the student handouts and use one of our sample rubrics to totally create lessons of your own where students are solving different problems, building different prototypes, and it's really easy to do that with the Blueprint kit. I included some ideas to help get you started. So maybe build a parade float that showcases a program from the school, or design a device that could help you with chores from home, or design a piece of equipment that could help clean up after an environmental disaster. So these are just examples of prompts that you can use without having, a full-blown lesson attached to it, that students can use the engineering design process and blueprint pieces to walk them through it. So now we're going to move on to little bits, and using the design process with little bits. We actually call it a little bit different, use a little bit different name, and we call it in little bits the invention cycle. So in the beginning of the presentation, I mentioned it can be used in all different ways, or the engineering process, design process can show up in all different ways. This is just a different way that it's showing up. It's a little bit of a simpler version, but still has the same basic steps. So create, play, remix, and share, and it's all in a circle. So you just keep doing those steps over and over and over until you're happy with the results. But again, creating is trying to build something that solves your problem. Then you play with it, you change it up to figure out what could make it better, and then you share it with your classmates or your team, and then you keep doing. So design is iterative. That was also one of my big phrases in the classroom. You never want to say, your first idea is good enough. You always want to be asking how you can make it better. And little bits makes it super easy to do that because the bits just snap together with magnets, and students can change up their design really, really fast and cycle through multiple prototypes in one class period. Students often get stuck though. They're like, well, I don't want to change it. This one works. So how do you get students past that? Here are some suggestions. If they're using little bets and they're like, this works, I don't really want to change it. Say, why don't you try adding a different input? Why don't you add in some sort of orange wire bit and see if you can create a different logic system? Or how can you add more materials to make it more fun? Can you add in a picture or something that is moving to make your invention more fun? So that's just a few ways that you can help get your kids kind of unstuck in that cycle. And then just some quick prototyping tips with little bits. A prototype is something that helps you model your idea, and then you can turn it into your actual final solution. Don't worry about perfection when you're prototyping. This one is hard for kids sometimes. They always want to do everything right the first time. And so they're a little scared to just jump right in. But don't worry about perfection. We often, my robotics students, I always say we learn more from failure than success. So making something that doesn't work, you often learn way more from than just making something that does work. So build more than one version of your prototype. Try something weird, try something unexpected. This is the time to test stuff like that. It doesn't have to be perfect. And when you're prototyping, document each step. If you know that if you build a prototype where something doesn't work, you want to document that, because if you know that it doesn't work, you're never going to go back to it. And sometimes students forget what they've already tried and what they haven't. So you want to document every point in here. And included in our Little Bits lessons, we do have student handouts that will walk students through the invention cycle that's up here, similar to the blueprint handouts. So with that, I will hand it over. Oh, one more slide. Why do I keep forgetting I put a third slide on these? These are two examples of using the engineering design process within the Little Bits kit. These are both included in the educator guide if you have that as part of your kit. So the first one is to invent an art machine, and the second one is to invent a self-driving vehicle. So if you have Little Bits and you're looking for activities to do, go to your educator guide and you'll find these two activities. So now I think actually with that, I will hand it over to Brad to talk about the design process with Bolt and Rover Plus.
Thanks, Adrienne. Great explanations of how you can use both Bolt and Little Bits, or I'm sorry, Blueprint and Little Bits. I'll talk about Bolt right now and how we can use that with the engineering design process. So something recently new we have created with our content for a bunch of our robots inside of Sphero EDU. We've created something called collections. And collections are just curated groups of different activities that are grouped together based on a topic. So there is actually an engineering design collection designed specifically for Bolt. There's 9 activities that are inside of that collection, and they all utilize the engineering design process. And in these activities, you are either engineering for Bolt to be able to do something or around Bolt to do something. I think we're getting the link in the chat there to that collection. It'll take you right to edu.sphero.com to actually check out that collection. There's some really fun ones in there, like building a bridge for Bolt to cross and testing that with different kinds of materials. Building a ramp to get Bolt to jump as far as it can. Different chariots to try and carry as much weight as you can, as quickly as you can. And one of my favorites, it's called hydrohypothesis. And since Bolt is waterproof, this is a water activity where Bolt becomes your engine and you're building a raft or a boat around Bolt to be able to carry a payload across the water. It's really fun activities. It's fun to use the water and do some cool things that way. There's also a little sneak peek there of some content that is coming your way sometime soon. So keep your eyes open for some new content coming in 2024. All right, let's also take a look at Rover. Rover is our kind of go anywhere, do anything kind of robot. It is super tough, has a ton of torque. It can carry a 3-pound payload on the top of it. It's programmed the same way Bolt or Mini is. So if you're familiar with Sphero EDU and programming that way with draw programming, block-based programming, or JavaScript, Rover is just the next iteration of that. But it's so much more because it's a development platform for us. So you can build on top of Rover with many other types of devices. So you can build structure, which we'll take a look at with the Blueprint Topper, which is coming soon. We'll look at that in more detail in the next slide. But you can also add things to the expansion ports of Rover. So little bits can be powered by Rover. You just plug them in USB, and now you have power coming to your little bit circuit. And you can use the sensors, all kinds of other things. They do not send data back and forth. However, you can use the trigger bit in little bits to receive a message, an IR message from Rover, because Rover, just like Bolt, has the ability to send infrared signals out. And then you can trigger things to happen. So you can actually control your little bit circuit right in Sphero EDU, which is really, really cool. Also, you can plug in microbit and Raspberry Pi. So if you plug in a microbit, now you're programming using MakeCode, and there's an extension. You just click on extensions inside of MakeCode, type in RVR and load that extension in there. Now you can program and control Rover right inside of MakeCode, which allows you to open up additional programming languages if you're familiar with MakeCode, and as well as Raspberry Pi. So Rover has both a USB port and a UART port, and you actually can utilize both those ports to program your Rover right in Python on the Raspberry Pi. So Raspberry Pi kind of becomes the brain of the operation here, and you program right in there, which gives you a lot of options to get your awesome inventions on the go. In the upper right-hand corner of this slide, you can see we got a little flipper that's triggered. This is actually a little bits circuit with a servo motor on there, and we are using that IR trigger bit to flip that flipper up to load the ball on top of there. So you can do some really fun things with some cool 3D printing and some other fun things that way. That little flipper mechanism is actually available on our Thingiverse site. So if you're interested, you can jump over to Thingiverse and search for Sphero and find some cool accessories for all kinds of Sphero products. Also, when we look at Blueprint, which I was just told, this is actually available now. That Rover topper plate for Blueprint is actually on our site and available for purchase now. But we have some quick start challenge cards that are available with this, and those challenge cards are on our website, that you can go on and download those and take your blueprint inventions and get them on the move with Rover. So 3 of those challenge cards are building a trailer. We can see 2 different kinds of trailers here that work with Rover, and a little bit of a push mechanism to collect a bunch of things, as well as a challenge to build Rover powered blueprint builds. So if we look at the model on the far right, we're actually using the treads on Rover to power the wheels and gear system here to build a winch using the blueprint parts. So really cool challenges you can do here to kind of level up your builds and do some really cool stuff to get those blueprint parts on the move. All right. With that, we're going to take a look at any kind of questions that are floating around out there. And I actually have one for Adrienne. I want to tap into some of your experience here in the classroom with the engineering design process. So when we look at the chart that comes with Blueprint, it's kind of in like a vertical line. But is there a point when you get towards the end of that that you could jump to a different step, like back in the process somewhere?
Yeah, absolutely, Brad. That's a great question. And I always remind my students that the engineering design process is totally fluid. So we have it laid out in steps and we have it laid out in an order, but at any time you can be jumping around, going back. This is not the oh, I'm lost for words. What the scientific method? This is not the scientific method where you have to go step by step by step in the same order every time. The engineering design process, you can jump around. Maybe when you're doing research, you find a prototype that has already been built and you can kind of jump right in to building that prototype to see how it works on your own. And I always tell people, as I always tell my students as well, prototypes can take a lot of different forms. So building a prototype out of Blueprint or Little Bits or Bolt or Rover Plus is always an option. But even just researching something or finding a simulator online or even drawing something up in a CAD software, if you have that to check geometry, check if things are going to stay together, that's also prototyping. So you can jump around in those steps, and it definitely does not have to be one by one by one in order every time. The Little Bits invention cycle does a better job of showing that circular motion, but really it's even more than that. You can go from step 1, 2, 3, down to 5, back up to 2 when you realize the design you decided on doesn't work. So you go back up to your brainstorming ideas, you pick a different one, go through the process again.
Awesome. Thank you for that explanation, Adrienne. That's something I feel like students and even some teachers get like caught up on, is like you have to go step by step and there's no point where like you jump backwards. And that's great to know that you can do that. One of the other questions that I just saw pop up here was, hey, that blueprint topper plate's really cool, but it's showing it for Rover Plus. Does it work on Rover as well? It actually does work on Rover as well. So if you have the original Rover that has the little blue button on the front of it, no worries. You can still snap that thing right on there and keep that working. There's a lot of similarities between those 2 robots. So if you need a new battery or anything like that, or additional batteries, you can still purchase the Rover Plus battery and put that in your old Rover. That'll work as well as the topper plate. Great question.
Brad, I have a question for you from the chat. Antoinette says, I haven't worked with Sphero products. Do you have online training classes? I would love to use the product in my classes.
Oh, that's great. I think I know somebody that probably knows the answer to that. As the professional development manager, we have offer all kinds of different training. So we have a on-site training where we actually come to you with up to 30 teachers. We travel to you. It's a customized training for us. We develop it after we meet with you of what exactly your needs are and develop that. We also have something called virtual all access training, which is a year-long subscription. You can go in and book training at any time that we are available in there in the calendar. And there's all kinds of different kinds of topics to talk about. We even have something called office hours. So if you feel like what you want to talk about that's Sphero related is not covered in one of those other sessions, no problem. You can book office hours and put that in there. We also have two other options. One that's brand new. We offer a 3-hour customized, we call it a half day virtual training. And just like an on-site training, we meet with you ahead of time and customize everything for your exact needs. And the last form of training we have is we have a bunch of courses called the Sphero Fundamentals courses. And you can go in and we have fundamentals courses on all kinds of products out there, whether it's robots or soon to be coming out there with Blueprint one. We also have for every other robot. So Rover, the regular Sphero Mini. We have even one for the indie fundamentals as well. So great question.
And we had one more question that I believe someone in the chat is answering, but I'll answer it live as well. A recording of this session will be available and it will be emailed to you along with the form for requesting a PD certificate after this is over.
All right. So let's see here. I think we're at the part where everyone is waiting for, right? That fun blueprint giveaway. So I believe you'll get a blueprint build kit after this. So we will reach out to you with shipping information and get that out to you soon. And our winner is Jacqueline Furster. Jacqueline Furster.
Congratulations.
Awesome. Well, thank you everyone for attending tonight and hanging out with us, taking some of your evening or afternoon. We greatly appreciate it. Keep an eye open for that follow-up email with a bunch of links and a PD certificate in there. If you do have questions, reach out to us at education@sphero.com. Of course, you can check out our website and hit us up on all the social media platforms that are listed there. We also do have a blog and a mailing list, as well as we have another upcoming webinar here in March. And I think tentatively it will be women in STEM that will be our topic. So please think about joining us again on March 19th. Thank you everyone for joining, and we hope to see everyone again.
Bye. Thank you.